friends, welcome to Pharma Toppers. I am Gaurav Das, Michael Mohali. Today I am going to discuss the topic of stereoisomerism. Okay, now what exactly is stereoisomerism? Stereoisomerism comes from the Greek word called stereos, that is nothing but called solid. When you are studying stereoisomerism, the first thing you need to know is you have to visualize everything in 3D. Whatever objects you see, you have to visualize that in 3D. You have to see the objects in front of us, not in this board, not in this paper and pen. You have to see objects in front of us, coming towards us, or coming on the back of us, away from us. Okay, what exactly is stereoisomerism? Stereoisomerism can be defined as compounds that have identical molecular and structural formula. However, they differ in the spatial arrangement of atoms in space. They have different arrangement in space. Because of this arrangement in space, we have different isomers called stereoisomers. Now, to elaborate on this topic of stereoisomerism, first I'll discuss about what is optical activity. Now, long back, hundreds of years back, it was observed that compounds are having optical activity. They are showing differential rotation in the plane of polarized light. Now, I have introduced a term called plane polarized light. What is plane polarized light? Now, when you have, the light waves can vibrate in many directions. That you see over here, can vibrate in various directions. Now, when you have a light wave vibrating in a single direction, that is called a plane polarized light. We have various instruments called polarimeter with us that can actually generate this plane polarized light. Now, when we pass a compound through this plane polarized light, we experience a specific rotation of the compound. After the active compounds, we experience specific rotation of this compound. This specific rotation is now given by the formula. Specific rotation is given by the formula of observed rotation divided by length. Keep in mind this length is in decimeter, not in centimeters. Many people do a mistake over here. Length in decimeter, and D is actually density of pure solid, or you can write a concentration of pure solid, concentration of any solid. So actually, for compound like 2-methyl-1-butanol, the specific rotation, this 20 and D, I am coming to this, is actually suppose minus 5.756. This is the observed rotation value. This is actually degrees. To write at minus 5.756 degrees, that means that 2-methyl-1-butanol is rotating the plane polarized light to the left by an angle of minus 5.756. Now this 20 actually is the temperature and D is the wavelength of light that actually use sodium light over here. D represents the D line of sodium, and this 20 is the temperature. This mentioning this is important because the degree of rotation can vary with temperature and also can vary with the wavelength of light. Okay, now you understood what actually is optical activity. Now we come to various terms regarding stereoisomerism that will experience, the basic terms that will experience. First term is enantiomers. What is actually enantiomers? Enantiomers are nothing, very simple line definition, that are mirror images that are non-superimposable with each other. So there's two divisions in this: mirror images, non-superimposable. So very common example is this that we see over here that exhibits a mirror image. This is a compound that you can see over here, a 4-carbon compound. This is actually a Fischer projection. We'll come to all this in the later presentations. We have over here Cl and Br and CH3. The mirror image of this is, you can easily understand that this is a mirror over here, and you can easily understand the mirror image of this is this. Now what do I mean is non-superimposable mirror image. What I do over here is not take this compound over here, pick it up and impose this on this. If we take this compound up over here and impose this on this, we see this Cl and Br is not matching. This is actually coming to this 2x. So this is not matching with each other. So it is non-superimposable mirror images. So mirror image and non-super. So this two A and B is a simple example of an enantiomer. Now next topic that we easily understand is diastereomers. Diastereomers, first very simple line definition is they are non-mirror images. They do not exhibit any mirror image relationship. These are compounds having same structural and molecular formula, but they are non-mirror images. Very simple example is the compounds over here. Similar set of compounds that we already earlier taken. We have this Cl and Br on this. This is actually another compound, same structural formula can be like this and this. You can easily understand this two does not exhibit any mirror image relationship. So this set compounds C and D are diastereomers. Now another very important differentiation of enantiomer and diastereomers are the physical and chemical properties of enantiomers are similar, and however for diastereomers the physical and chemical properties are totally different. They can be isolated and they are different. Now we come to another set of compounds known as meso compounds. This is very important, that will come in the previous, that will come in this discussion. This what we have over here is tartaric acid. This is tartaric acid. Now this, if you see that this end carbons are similar, and if you divide this compound through this, you can exhibit that this part is actually equal to this part. This part and this part is exactly similar to each other. So this is actually, this can be compounded divided into equal halves. This is nothing. This is also called a plane of symmetry. You can also write this as a plane of symmetry. So compounds are like this, which is having a plane of symmetry, are actually known as mesocompounds. So this type of compounds are optically inactive, and this type of phenomenon is known as internal compensation. Like we have this compound over here, the rotation exhibited by this part is cancelled by the rotation exhibited by this part. So this is actually some case of internal compensation where the compounds are optically inactive due to internal compensation. Okay, this is actually mesocompounds. It's a case of mesocompounds. We have another case where we can see racemic mixtures. Racemic mixtures are those compounds where they exhibit an equal proportion of both enantiomers. Like if we have a compound having an equal proportion of one enantiomer and another enantiomer, those compounds are known as racemic mixtures. This is also known as external compensation. External compensation. Like if we have 50% of D and if we have 50% of L of suppose tartaric acid, 50% D and 50% L. 50% D will have a rotation towards one part and 50% L will have a rotation to another part. So they will be cancelling each other, and such a mixture is known as a racemic mixture.